Hello world. Okay, so in this tutorial here, we're going to do some more Haskell, but specifically we're going to do list comprehension. So we'll go ahead and start our compiler here. Okay, so let's get started. List comprehensions, you may be used to them in mathematics, but we're going to use them here in Haskell. So let's say we want to print the list of all even numbers from 2 to let's see, 2 to, we'll do 20, right? So that's one way that we could do it using the range that Haskell provides. But there's another way that we could do it as well using the list comprehension, and that's something like y times 2, y belongs to this list from 1 to 10, and we end our list comprehension, and we see that we get the same result, just written in a different way. So two different ways to do the same thing, practically. But now let's say we just want all the numbers that are greater than or equal to 14. So how would we write that? So I put back the same equation here, but now we can do what's called a condition. I think another word for it is filter, and another word for it is predicate. So let's put a comma here. Let's say where y times 2 is greater than or equal to 14. So that's the condition I have. And so now you see we just get back the list 14, 16, 18, and 20. So that's pretty cool. Let's do something else then. Let's say that, I don't know, let's do list comprehension. Let's say y, we want to return y's. Y will belong to the set from 10 to 30. Okay, and let's put in a little condition there. Mod x 7. So when x is modded by 7 and the remainder is 3, we want to, oh, not x, I'm sorry. We're going to do y. So when y is modded by 7, when the remainder equals 3, we want to return all the y's of that result. So all the y's that are divisible by 3 from the range 10 to 30. So let's see. Okay. So let's see. 10, we get, so, oh, wow, okay, so yes, so 10 mod 7 is equal to 3, 17 mod 7 is equal to 3, and 24 mod 7 is equal to 3. So I'm going to do the same thing, and let's say we want everything that's divisible by 7. So before, it wasn't divisible by 7 because we got a remainder of 3, but now because we have the remainder of 1, it's going to be divisible by 7. So let's see if there's any of those numbers in here. So we have the number 14 is divisible by 7, the number 21 is divisible by 7, and the number 28 is also divisible by 7. Okay? And one more thing what we can do, of course, we can rewrite this such that y mod 7. So that's just another way of writing the function again, and we see that we still get the same result. So however you want to write it is all up to you. So let's create a function, and I call it let's call it happy sad function. It's going to take in x's, and if x is less than 10, then we are happy. Else it's greater than or equal to 10, then we are sad. And x is going to belong to x's. So remember that when we're creating a function called happy sad, it's taking in something here. In this case, it's a list. And we're going to have this x here that's going to belong to the x's, to that list. So x is going to be one element within the list of x's. Okay, and we want all the odd x elements. So again, odd is a function, and we're going to return all the odd x there. So let's see. So we just not created it. So let's say happy sad, and I'm going to take in a list 7.13, and so we get happy, happy, sad, sad, and our list 7.13. Let's see how many odd numbers there are. 1, 2, 3, and 4. So we return 4 for the results. And remember, if x is greater than 10, then we're going to say happy. So the first one is 7. 7 is less than 10, so it returned happy. The next one is 9. 9 is less than 10, so it returned happy. The next one is 11. 11 is greater than 10, so it returns sad. And last but not least, 13. 13 is greater than 10, so it returns sad. Woo, okay. So that's again using the list comprehension to this time to define a function. Okay, so that's all good. What we can do is we can add in multiple predicates or conditions or filters, however you want to say it. So let's say we have x, and x belongs to the range 10 to 30. And we want to return everything. We don't want to return 20, so anything that's divisible by 20. We don't want to return, x not, we want to return x not equal to 20. We want to return x not equal to, we'll do 10. And I want to return x not equal to 30. So, bam. So in this right here, we should the result should be with no 10, no 20, and no 30. So we should not see those 3 numbers in our list. And that's exactly what we get back here. Okay. So let's move on here. Let's see. We can do some other cool things with list comprehension. Let's do a multiplier. X times y. X can belong to 2, 4, 6. And we can let y belong to 3, 5, 3, 5, and 7. Okay, and what we want to do is we want to return the list of x times y greater than, actually, let's not put this, let's just see what this results in. And so what you see is you see the multiplication of each of the elements of the list. So first we have 2 times 3 gives us 6. Then we have 2 times 5 gives us 10. 2 times 7 gives us 14. And then 4 times 3 gives us 12. And 4 times 5 gives us 20. And then 4 times 7 gives us 28. And then, of course, it starts with 6 times 3, which gives us 18. And then 6 times 5, 30. And then 6 times 7, 42. Okay, so now let's put a little condition in there. So I want to only print out x times y greater than 20. So hopefully it just prints out 28, 30, 42. So let's see. And that's exactly what it did. All right. So let's define another function. There's a function called length already, but we're going to write our own version of length. So length, and I'm going to put a little marker there, I guess what they call it, I forgot the exact term here, but they put this here to basically say that there's already a function called, length, but actually let's just call it length n for new, but there's already a function called length. So length is going to take in a list. We're going to call it x's, and that list we want to use the sum function, and the sum is going to sum everything in this list that we're about to create now. So in our sum function, we're going to turn 1, and we're going to get the element. We're going to go through the element x, which belongs to x's, to the list x's. Okay, so let's see. Let's run it. Okay, so now we have length n. If I do 1, 2, 3, we see that this is a list of length 3, and we get 3. Let's add some more elements. So that's 4 elements. This is 5 elements. Let's see what we get. We get the number 5. Now, let's rewrite this length function, a new one. So I'm going to call this length m, and it's going to take in x's. It's going to equal to the sum, and remember again, sum is a function, and we want to return 1. And this time I'm going to put a space here because we actually don't care about that variable x because it's never used. And let's see if we get the same result. Length m. Let's go with 1, 2, 4, 5. So that's 1, 2, 3, 4 elements. And you see that we still get 4. Now, the underscore means that we don't care what we'll draw from the list anyway. So instead of writing a variable name that we'll never use, we just write the underscore. And just so you know, that list that we just created, this one axis list, we actually have to put in a list here just so you can see what it's going to do. Let's say list is 1, 4, 5. Okay, and what's this going to do? Well, it should just print out 1 3 times. So that's all it's doing, is printing out 1 3 times. So it just gives us a list of 1s because it's going through this list here. And sum takes in a list and adds the elements of that list. So for instance, if we had 1, 4, and 5, you see that we get 1 plus 4 plus 5 equals 10. So of course, when we add the sum of 1, 1, 1, we get 3. So that's all that it's really doing. I hope that wasn't too confusing there, but essentially that's it. Okay, well, I think that's it for this video, guys. I hope this was very helpful, and I will see you all in the next video.